In this video, we will talk about derivatives of other trig functions. So in our first example, I want to show what the derivative of tangent of x is. Okay, so for this one, I'm going to just get into the proof. And after I work out the proof, I will discover what the formula of tangent of x is. Rather than in the previous video, I just told you what the derivative was and then we verified it. Okay, so let's prove this. So luckily with tangent of x, I don't need the definition of the derivative. Because if I let f of x be tangent of x, I can rewrite this as sine x over cosine x. And we now know the derivatives of both of those functions. So to take the derivative now of this fraction, I can use quotient rule. Okay, so we can use quotient rule. So that'll give us f prime of x, our derivative, is the bottom function, cosine x, low, d high. So d high is going to be the derivative of the top, derivative of sine x. And then minus high, which is sine x, d low, so times the derivative of the bottom, times the derivative of cosine x. All right, and all over low squared, so all over. If I square the cosine, I'll get cosine x squared. All right, so we have f prime of x, our derivative, equals cosine x times the derivative of sine x is cosine x. And then we have that minus sine x times the derivative of cosine x is negative sine x. Right, we saw that in the last video. All over, and I can rewrite this denominator as cosine squared x. That's our notation for doing a power on a trig function. Cosine squared, we put the square right there. Okay, so this equals, on the top, notice I have cosine squared plus sine squared. And that's just one, that's our key trig identity. And then over cosine squared x. And 1 over cosine squared, well, 1 over cosine is secant. So this is 1 over cosine squared, which is secant squared x. Okay, and we've just found our formula. The derivative of tangent x is equal to secant squared of x. I'm going to highlight this. So this one is easier to do than the derivative of sine because I already had the building blocks for this. Tangent I could rewrite in terms of functions that I do know the derivative of now. I know the derivative of sine and I know the derivative of cosine. Okay, let me put square here because I was proving this technically and shade that in. So I want to end this video by just writing the derivatives of all of our kind of standard trig functions in a table. So we've seen the ones in this left column, derivative of sine, cosine, and tangent. So recall that the derivative of sine x is cosine x. Derivative of cosine x is negative sine x. And now we've seen what the derivative of tangent is. This is secant squared, and this one involved using the quotient rule. Okay, so I'm going to just tell you what the derivatives of these other three trig functions are, and I'll briefly talk about, well, how would we show them? Okay, derivative of cosecant is negative cosecant x times cotangent x. The derivative of secant x is secant x times tangent x. And the derivative of cotangent x is negative cosecant squared x. So proving these three formulas, this is actually going to be a homework exercise, but it's not bad at all. The proofs are going to be similar to how we did the derivative of tangent of x, because with tangent of x, I got to rewrite it as sine over cosine, and we know those derivatives. And then it was using quotient rule. Similarly with cosecant, secant, and cotangent, we can rewrite all of them in terms of sines and cosines. So those derivatives are going to be really similar to how we did the derivative of tangent. So in terms of our goals for this section, we finished goal 2, talking about how we compute the derivatives of trig functions. We'll get more practice with these, doing actual problems where we find derivatives that involve trig functions in our discussion videos.